Well, hello everyone. Chris here with a little FreeCAD live stream on a nice sunny, cold Sunday afternoon here in Northeast Ohio. Got a little project here that I'm going to go through that honestly, I've had this textbook since I was probably in high school in the 90s, and I've probably drawn manually like on a drafting board, a lot of the things out of this textbook. Um, but we have a lot better technology these days, and this is a good, just as good a practice as anything when it comes to practicing creating 3D models, things like FreeCAD, SolidWorks, any kind of modeling software. The more you do it, the more tricks you learn along the way. And noticed over on Mastodon, a lot of people were saying that they were looking for tips, ideas from someone who's been doing this for a long time to sort of help them figure out how they might approach something like this. And I thought this was a good example because you know as a mechanical engineer who's done a lot of different kinds of design projects through the years, I've worked around manufacturing and CNC machining and designing fixtures and whatnot uh, from time to time. And something like this Vise might be something you might have to create if you're figuring out some sort of CNC setup or figuring out how to fixture things. Or you might create it once and use it forever, but you got to start with the model if you don't already have it. So what I thought I would do is try to get through as much of this as I could in an hour, and hopefully it's helpful. And I'm just going to go through and model the parts how I would approach doing them. And then if I don't get through all of them on this stream, I might do another one, and then also kind of go through how I might create the assembly up here in the corner of all the parts using, say, like the assembly 3 workbench. So I'm using FreeCAD, the link stage branch. If you really want to go out and find the actual version that I'm using today. Real Thunder, updates it periodically as he makes revisions and whatnot. But a lot of the techniques and stuff I'll do here kind of apply regardless of what software you're actually using. So, hey Thomas, glad you could join here, and hopefully this is helpful to you. Feel free to post any questions down there in the chat, and I'll try to answer them as I go here. So, for this particular thing, what I'm going to do, oh, and you'll also have to forgive me that I'm going to be doing this using imperial units. And fortunately, with FreeCAD, you can type all these fractions in, and it'll convert them to decimal equivalents. But ultimately, the numbers don't really matter because it's all going to become decimals anyway. And whether you're in millimeters or inches, uh, it's just pretend this is a very small machine vise, 1/25th scale. So what I thought I would do here is maybe start with some of the simpler parts. I'm not going to get into a lot of the threads and whatnot, unless, except for maybe the Acme thread on here, but a lot of these holes, I'm just going to let them be more simplified because that's how, in most cases, a lot of drawings don't have detailed threads on them. And so I think I'm just going to start with this key up here. It's pretty simple part. And so create a new file here. We want to make sure we're in the part design workbench. I'm going to actually create a part. And the reason I'm going to do that is because I want to use this in an assembly later, and it makes it easier to insert those in the assembly 3 workbench. So I'm going to create a part. I want to create a body within that part here. And before I get started, I'm actually just going to save this into my FreeCAD tutorials machine vise. Let's see, what item was that? Number 6. So I want to call this file 6 dash special and save it. And I'm also going to rename the part here to 6 dash special key. All right. So from here, I like to turn on the origin. I think by default, I guess you can see the axes are a little bit hidden, but I like to be able to see the planes I'm going to start with. So let's take a look at this part. And if it were me, I think this could all be done really with a sketch and an extruded pad. There's no real reason to do this, with multiple features, though you could. And I suppose I could show you a couple different ways of doing that. So I'm just going to start with, I know the shape is roughly a horseshoe. So I'm going to come in here and click on the XZ plane. It doesn't really matter necessarily the orientation for this. I suppose we could use the XY plane, and maybe I'll just do that. So I'm going to click on the XY plane, choose create a sketch, and then we're going to go in here and I want to draw a circle. I'll draw another circle for the ID here. Going to just create vertical line. Create another vertical line here. And then I'm going to trim that arc, trim this arc, then make this line and that arc tangent, and make this line and the arc tangent. And FreeCAD was warning me of some redundant constraints there. And I'm not exactly sure where the redundancies are. It doesn't like when you have a piece of geometry defined or constrained using multiple constraints that effectively do the same thing. So it was just letting me know that it removed some redundant ones there. So now you can see as I move this around, these lines are nice and vertical. They're tangent here. And the only thing I have to do at this point is add some dimensions to this. So I'm going to come in here. Now you have to forgive my screen's a bit truncated. So I'm going to apply a diameter constraint to this outer circle, and also I'm going to put a horizontal dimension across these 2 points. And I don't remember what those dimensions were off the top of my head. I'll have to go back to the picture here, but that's the great thing about this. I can define them and then change them later. So let's go back to the image. So it's 23/32 and 25/64 there. Okay, so double click the dimension, 25/32. No, 25/32. So that's that decimal equivalent. And then this was 23/64, as I recall. Let me double check that. 25/64. Okay. And then I think it said that it was, I'm actually going to split the, go for the middle of the tolerance here. So that would be 0.12, what would that be? 0.1235 inches. So we'll close our sketch, and now we'll do an extruded pad here. Want to make it 1, 2, 3, 5 inches thick. Hit OK, and there is that part. And really, that's pretty much all there is to that. I could have drawn the outer circle and then come in and done this slot in here as a separate pocket, and that would be just fine. But this can all be done in one feature, and the simpler your model tree is, I don't know, I think the better. in general. Just and now I could go in here if I really wanted to, and I could come into any one of the on my sketch. I could come in here in either one of those two dimensions. I could edit them right here. I could have named those dimensions if I wanted to, but I could edit these directly here, or I could right click and edit the sketch and come in and change these dimensions. But that's just how I would approach making that part. So I'm going to save that and move on to the next part. Turn those off. I hope everyone can hear me okay. This is actually first time doing this whole YouTube live stream thing, and oh, and I realized I misspelled that file name. That's really nice. All right, so I've created a new part here. Let's move on to another item on this here. What shall we go with? I want to go with the jaw plate here. So let's see. All right. Again, I've created a new file. Create a part, and then we'll create a body within that part. Rename the part to, I believe it's 3 jaw plate. Before I save that, let's double check. Yep. Okay. And then we're going to just save the file here, and we'll call it 3- jaw plate. So let's take a look at this. So this is actually, mostly again an extruded part. The note here calls for these holes to be drilled for a 1/4 inch flathead machine screw, and I think I may do a little improvising on the fly here. But I think I'm going to use a hole feature here in FreeCAD for this. So, but the first thing I want to do is I want to create the sort of rectangular prism here. So come back over to our body, turned on the planes. We'll pick the, in this case, I'll pick the XZ plane, create a sketch. I'll come in and create a rectangle. Want this to be symmetric about the vertical center line. So I'll pick those 2 points, vertical, or I guess that would be the Z-axis here. Choose symmetric constraint. I know that there's a width and height to this, so I'm going to add a horizontal dimension. I'm going to add a vertical dimension to that line. I don't remember what they were, but we can change it after we look at the drawing. So it's 1 3/4 inches tall by 2 3/4 inches wide. So this is 2.75 inches and 1.75 inches tall. So now that I have that defined, close the sketch. I'm actually going to turn off the planes so I can see that sketch a little better. Choose the sketch. We're going to pad that 3/16 of an inch. So come back over here and we're going to pad that. I'm actually going to go the other way. 3/16 inches. Okay. And so there we have the base here. And so now to add these holes in, again, I'm going to use the hole feature in FreeCAD, but the first thing I have to do is I have to define where the centers of those holes are, and I have to do that with a sketch. So I'm actually going to choose this surface and to create a sketch, and I want to go in here and draw 2 circles, and I want to select them, make them equal diameter. And these circles don't actually have to be the same diameter as the hole you're going to create. They're really, FreeCAD is just looking for the centers of these circles. So I'm just making them equal for my own convenience. I'm just going to apply a diameter constraint to those, and I'm just going to make it 0.25 inches because I know that it was a 1/4 inch diameter screw. I also know that these are going to be symmetric. Well, I guess I don't know that. Let's look at the part. I'm assuming that they are symmetric about the center line, but let's just say that's not explicitly defined here. They give you a dimension off of this edge and the distance between them, but they are on the same horizontal center line, an inch up from the bottom. So what I'm going to do is I'm going to dimension this exactly the way it is on this drawing. And so first I'm going to make these two horizontal with each other. I'm going to add a, oh boy, I think I just need to move this toolbar to right there. That way we can see all of the constraints. So I'm going to add a horizontal. Oh, I just realized something I forgot to do. So I'm going to add a horizontal dimension here, which I think was 1.5 inches. And then I know that it's an inch up from the bottom. So we'll pick that point and say this one. That's an inch up from the bottom. But then how do we get this to be that dimension off of that edge? Well, the way that you have to do that is you have to use the add external geometry tool here. And what that will allow us to do is I can pick that edge right there, and that'll be it references the edge of the pad that we created before, and if I change that pad, this will move along with it. And the one thing I'll say about this is that doing this is okay, and referencing other geometry and previous features is okay, but the thing you have to keep in mind is that if you drastically change the geometry of the previous feature, FreeCAD may lose track of where this edge actually is, and that you'll hear about the topological naming problem within FreeCAD. And here in the link stage branch, it doesn't seem to be as much of an issue because I think that Real Thunder is taking care of a lot of that, but it isn't in the main branch if you're using that. But it's just something you have to keep in mind. And this same thing applies in SolidWorks. I use SolidWorks in my day job, and I break my models frequently if I change things drastically, but that is the sort of the thing you have to keep in mind as you're modeling is like using this edge is perfectly fine, but if you delete something that defines that edge, well, you have to fix it later. And it's just part of the design process. It doesn't matter. It's not something that's limited to FreeCAD. It's the same in all, or I shouldn't say all, but most 3D CAD software. So I've picked that edge to use that as a reference edge. And so we'll go back and view the sketch head on. And so now I can apply a horizontal dimension from that point to this point. And I know it was 5/8 of an inch, so I could just type it in 5/8. And then let's double check this dimension here. Okay, it's 1.5 inches. All right. So we've got that sketch defined for the centers of the holes. And now with that sketch selected, I can come up here to the hole feature, and I want to make this, I guess I can do a countersink. And the hole size, I guess, because I'm not doing a threaded hole, I'm just actually going to make the diameter something slightly larger than the 1/4 inch. I'm going to use 9/32 because that's typical clearance hole for a 1/4 inch bolt. The hole depth will be through all because I want to go all the way through my part. And then on the countersink diameter, it's going to be an 82-degree countersink angle. The diameter, do not believe, is going to be 15 inches. I'd have to look it up in my machinery's handbook to see what the actual countersink diameter is, but let's just say that it's 1/2 inch. And say okay. And so now we have a countersunk hole for a 1/4 inch screw in the face of that. And we could always come back and change these diameters later. I apologize for my dog. Must be barking at the Amazon delivery. So now that's pretty much all there is to this part. It's a little hard to see in this view right here, the way they have it drawn. You can't really see the tapered countersink angle here. But again, we can always come back and modify this if we want to make sure that that countersink diameter is what it needs to be for a flathead screw. So that's all there is to this jaw plate. And so we will save that. And I'm actually going to just close that and close that file. And we're just going to create a new file again and move on to the next part here. So let's see. All right, I'm just going to do this handle rod then. Pretty simple part. All right, so let's create a new part, create a body within that part, and then let's rename this to 7-handle rod. Is that right? Yes. And we'll save the file and we'll call it 7-. All right, so now let's turn our planes on. Again, this is just a simple extrude. I could do this as a revolve if I really wanted to. Revolve a rectangle around this center line. But I don't think that that's really advantageous in this particular case. Again, this is a really simple part. For something like this, the Vise screw here, it might be more advantageous to do this as a revolve, but in this case, I think it's just faster and simpler to do this as a extrude. So it's going to be 0.3115 diameter by 5 1/8 long. Okay. So we're just going to pick the XZ plane, create a sketch, draw a circle, add a diameter, 0.3115. Close the sketch, extrude this. But in this particular case, I'm actually going to make this symmetric and make the total length 5.125 inches long. Because when you assemble the vise, I know that it shows the vise handle being all the way to one end here, but when you assemble it in the assembly I'll do later, you might want to have it centered on the actual screw when you assemble it. But I guess in this particular case, it doesn't necessarily matter, but it will actually help us with the locations of these holes here, because they're the same distance in from each end. And I can make those holes symmetric about a horizontal center line, and I can simply define the dimension from one end if I want, and then the other end can follow. And it just takes minimal dimensions and constraints. But anyway, let's see. So yeah, we got the length, we have the diameter. So there we have our pad. And so then the next thing I'll do is I'm going to add these holes in, and to do that, I'm just going to do them as an extruded pocket here rather than a hole. And the reason I'm going to do that is I can pick now the XY plane, create a sketch, and now I can draw two circles. They're a little hard to see, so I'm actually going to just hide that pad for a second. Where do my circles go? Oh. Let's try this again. Draw a circle. A circle. All right, they're going to be the same diameter. So we'll select them both, make them equal. I don't remember what that diameter was. Let's take a look. Number 37 drill. I don't know if I know what that is without looking it up. I'm going to say that it's, oh, that's a good point there, BB. Yeah, it's, there's lots of ways I could have oriented this. And sometimes you do it one way and you think, oh, I should have done it the other way. And then you go back and change it, you know, but that's okay. I mean, it's, all of these decisions I'm making are kind of based on, my personal experience creating these. So I've made a lot of mistakes through the years. And so anyway, now that I get these two holes, the diameter of them, again, a number 37, I'm going to guess is somewhere, without looking it up, around, maybe let's just call it 3/16 of an inch or something. I'm just going to pick that and make it 0.1875 inches. So those two, you see, they both shrank. Oh, thank you. All right, I'll make it what it should be. 0.104. All right, thanks for the help there. So now we're just going to make these two symmetric. So I'll pick the center of the circle there. Hold down Control, pick the center of the circle there. Hold down Control and pick this axis and make them symmetric. Let's turn that pad back on. And now I'm going to pick the end of my shaft here as a reference edge. And then that will allow me to come in here and add a dimension from the end of, I think it's going to be 0.375 inches. And then I picked that because it says here to drill it with this item number 8, the handle ball, and it's 3/4 of an inch in diameter. So I'm presuming that the hole is going to be halfway in from the edge, and so we're going to go, that'd be half the diameter of that ball. So again, we could always change this later if we really wanted to. So I'm going to pick close. So now I have the two, what's going to be my holes here, and I'm just going to pocket that through all, symmetric to the sketching plane. So you can see it's going to cut all the way through in both directions, and hit OK. And there, now I have the handle rod. Hope that all makes sense. Turn off my planes there, and then I'm just going to save that. So let's move on to another part here. All right, you know what? Actually, I think I'm going to go on to the Vise screw here, because this would be a good chance to show how I would do this with a revolve. And so let's come back over. I'm going to close this file, create a new part. Is this number 5? Number 4. Okay. Create a new part. Create a body within the part. To number 4. And then we'll just save the file. All right, so let's turn our planes back on. Now let's take a look at this thing here again. I could actually see doing this as, let's say, 1, 2, 3, 4, 5. You could technically do this with probably 6 extrudes. You just extrude this 3/4 inch diameter, then extrude the little relief here for the threads, then extrude the diameter for the threads, then extrude this smaller diameter out here, then extrude the relief out here, and then extrude the final bit. And that would be fine. All the dimensions are given here. In fact, these, excuse me, these length dimensions, and you could go through and do it that way. But that would take 6 features to do that. And if you wanted to change any one of these dimensions along the way, you'd have to remember which feature that dimension was in and go over and edit it. And then you have to edit it in the individual features. Or you could have one sketch and have all these dimensions in the one sketch and edit them all within one feature. You have a sketch and a revolve. Again, that could be a matter of personal preference. But things like these relief grooves here are best done as revolves anyway. And because if you kind of think about the way this part would actually be manufactured, it would be machined on a lathe. The part's rotating. You're going to use a grooving tool to come in here and cut this groove. So revolved cut kind of makes sense in terms of how it would be produced. But again, you could do it with a extrude of the smaller diameter and then come on off the end of that smaller diameter with a larger diameter and extrude it out. But again, I'm just going to do this as a revolve here. So I'm going to come over here, pick the YZ plane and create a sketch. And I guess it doesn't necessarily matter where I start here. I could use, say, this, the face that defines the end of this larger diameter as a reference point off of my origin and have this end hang off to the side, or I could simply use the end of the part as my reference. I could use this end as the starting point. I could start anywhere in the middle. It kind of depends on what your design intent is. What's your important surface on this? Well, I don't know exactly what the important surface was on this particular design. I'm just recreating it. So I'm just going to pick the end surface of the part just for convenience's sake here. So oh, you're very welcome. So let's come back over here to our sketch. I'm going to use the polyline tool and I'm not going to start right at the origin. I'm going to draw it kind of offset here a little bit because it'll give me a little bit of, it'll make it a little easier to connect up to this at the end. So I know I've got a horizontal edge. I'm going to have a little relief here. I'm going to come up a little bit. Then this is going to be the threaded part. And then it steps down again, comes over. There's going to be another groove down here at the end. And then there's a little bit off the end of the shaft. And then we're going to come down and I'm going to connect back up over here. And what I've done here is I've basically roughed in, move this over a little bit. What I've done is I've kind of roughed in this overall profile, if you can imagine that in cross section. But I haven't assigned any dimensions to anything. I just know that that's the general shape, because we can always draw the shape and then add the dimensions later. So what I'm going to do here is, now that I have some of these in here didn't come out being horizontal or vertical. So I'm going to make this one vertical, make this one horizontal, make this one vertical. Oh, this one's going to be vertical as well. I just didn't get close enough when I was sketching it to snap them automatically. I also know that this diameter and this diameter, they're going to be the same. So I'm going to pick this point and this edge and use the point on object here so that they stay in line with each other. And zoom out here. Oh, this one should be vertical. And so I'm going to be rotating around this edge. So it needs to be on the horizontal axis. And this is to the end of the part, and it needs to be on the datum axis here. So I'm going to pick this point and the origin and make them coincident. And so now it comes to adding the dimensions. FreeCAD doesn't have an option, kind of like SolidWorks does, where I could pick, say, this edge and the axis of rotation and apply, let's say, a vertical dimension here, and it would give me the diameter. I only have the option to put a vertical dimension from there to there, and I have to know that this is going to be half the diameter that I'm trying to create. And so it requires me to do math, and I'd rather not do math along the way if I don't have to, because that's an opportunity for a mistake. You can do it this way. I just don't think it's a robust way of doing it, because I think in diameters instead of radiuses. I don't go by 3/8 radius round bar when I want 3/4 inch diameter round bar. So what I like to do when I do revolves is I like to draw a circle in a convenient location, and then I convert this to a construction circle, and then that allows me to apply a diameter to that of 0.75 inches. And that way I know that this line is going to be it's going to end up being a 3/4 inch diameter in the end, a 3/8 radius automatically, because the circle is at its center is at the axis of rotation, and it's coincident with the line for that diameter. I could come in here and do the same thing for this diameter, which I'm pretty sure is a 1/2 inch. So I want to come in here and draw a circle from there to there, make this construction, just select it first, make it construction. The thing I have to keep in mind is whatever point is going to be my tangency for the circle has to be directly above the center. So I'm just going to pick this point and this point and make them vertical with each other. And now I can put a diameter dimension on here of 5 inches. I also know that this diameter here is 5/8 because it's a 5/8 Acme thread. So I'm not going to, I could put the other construction circle right here and go to this point, but I think it makes things a little bit cluttered. So what I'm going to do is I'm going to come over here and I'm going to draw another circle, except I'm going to go out there to that point, but I need to make sure that these 2 points are vertical with each other. I'm going to make this a construction circle, give it a diameter of 5/8. All right, so that's defined. Do the same thing down here for this groove. Let's draw another construction circle there to there, make sure these are vertical. Make this construction. Again, the order of all this doesn't really matter. I don't remember what this diameter is, so I'm going to leave it with that for right now. And then finally, we're going to do the diameter of whatever this end of the shaft is down here. We'll do the same thing. Draw another circle. Make this construction. Give this a diameter. And again, I don't remember what it is, so I'm going to leave it at that for right now. But we can always come back to the drawing. All right, so it's a 1/2 inch on that end, and the groove diameter is 3/8 of an inch in here. So actually what this allows us to do is, instead of having that on this end, what I can actually do now is, because this diameter and this groove diameter over here are the same, I can just make these 2 points horizontal with each other, and now the diameter of this and the diameter of this will be the same. So that's a little trick there. We'll make this 0.375 inches. And so now I have all the diameters defined. And so now I can go in here and start adding some horizontal dimensions. And so let's take a look at the dimensions here. I know that the width of that groove is 1/4 of an inch, and that is 13/16 over here on the end. So I'll come in here, put a horizontal dimension of 0.25. I'll put a horizontal dimension on that line of 13/16. So those are now fully defined there. So then what do we have over here? So this groove is default shortcuts for toggling construction lines. I don't actually use the keyboard shortcuts so much. I typically tend to use the the button on the toolbar up here for toggling between construction and I guess you can see the keystrokes there, the G and I tend not to use the key shortcuts here in FreeCAD. I'm more of a, it's weird. I actually use keyboard shortcuts in a lot of other software, but for whatever reason, FreeCAD, I don't. So sorry, I can't answer that, Thomas. Let's see here. So let's go back to the part. So I know this groove's 1/4 of an inch in. It's roughly 0.1295 wide, averaging those two. So let's come over here and define that. So let's apply a horizontal dimension of 0.25 there. Let's define the width of the groove here of 0.1295. I think the next thing I'm going to do is define the overall length of 6.25. So let's do that. 6.25. And then the last thing I should need is the length of the threads. Let's clean this up a little bit. Again, I forgive the fact it's all in inches, but again, just pretend it's a 1/25th scale metric vise. 3 15/16 is the length of the threads here. So we'll just do another horizontal dimension. I just happen to know that is 3.9375 inches. Over 20 years of inch dimension to decimal conversion, fractions to decimals, I have a lot memorized. Okay, so now you see the sketch is fully constrained. So now we should be able to close that and sketch. And now we can revolve it, but that is really the wrong axis. And it's because it chose the vertical sketch axis. We can choose the horizontal sketch axis and boom, there you go. There is the basis for our vise screw. Again, we don't have the threads here yet. I may not put them in right now, but we'll at least start with this. So let's turn off our planes and save it. Let's take a look at the part. Well, I can see here there's a radius on the end here. And I think that's the only, other than this hole, I guess I can go in here and add the hole in. So we're going to do that the same way we did the other, on the other handle. I'm going to actually turn my planes back on. This time I'm going to pick the XY plane, create a sketch, reposition it. We'll go in here and draw another circle. Define its diameter. Again, I don't remember what it was, but we'll fix it later. And then I think it was 13/32 from the end. I should know that one. Let's see what the diameter is. 11/32. All right, so that is all right, so now that hole or that circle is fully defined. Close. We'll do a pocket, through all, symmetric to the plane. Okay, boom, we have our hole. And now the last thing here is we'll put this the radius on the end. So we'll add a fillet, even though it's technically a round, not a fillet. And it is 1/16 inch. And there we go. There is our, and you'll notice, I think it's just a matter of the angle here. Hey there, Mr. Maker. Glad to see you. I think it's just a matter of projection here, why this looks shorter, but I've made it to the actual dimensions. And so I know that this is actually correct versus whatever angle of projection is, probably 30 degrees, even though slightly less. So that is, I'm just going to leave that screw as is for now. I'll just save that. And because I only have 14 minutes to go here, let's take a look at another part we could do here. Maybe I'll get a start on, or maybe I'll take a look at, I'll do this collar down here. So let's close that file, create a new, and we'll create a, what's the item number? Oh, I used to do that kind of stuff on the drafting board, and when I had to ink it, boy, if you made a mistake or got your T-square a little too close to the vellum and the ink bled under your T-square, oh, it'd make you crazy. But that was many moons ago. So let's see here. It's number 5. So let's create a new part, create a body within the part. But let's rename this to be 5 dash. Is that what it was called? Just a collar? Yeah. And then let's save the file. 5 dash. I'm just naming these based on their item numbers and description. I could give it whatever name I wanted if I wanted to have my own part numbering scheme, but I'm not, that's not what I'm here for today. So this one really looks like it's just going to be a simple extrude to get the main body of it, and then another extruded cut in here or pocket to do that slot. And then I'll come back later and put these actual threads on it later. But so let's come back over here. We'll turn our planes back on. Just pick the XC plane, create a sketch, draw a couple of circles here, add some diameters. I don't remember what it was. I'll just add 2 diameters because we'll just fix them here in a second. 23 30-seconds and 33 64ths. 23 30 seconds. So there is the basis of our initial extrude. It's fully constrained. We'll just pad that. We'll go back the other way. How far does it need to go? 13/16. So 0.8125. I just happen to know that one. All right, so I've got the base there. Now we need to put that cut in on the end, this little slot. So I'm going to pick the XY plane. Let's create a sketch. We're going to create a rectangle here. I'm actually going to make that point and that point symmetric to that axis. Then we'll put that line on that point. I'll just do a vertical dimension there and a horizontal dimension here. Let's look at what the actual dimensions are. 3 30-seconds wide and an 1/8 inch deep. So 1.25 and then 3 30-seconds. So that's fully defined. So now we'll just do a pocket through all, symmetric to the plane, and boom, there we go. We got that. in there. And again, we're missing the threads that are on here. I'll come back and put these in later. That is an oddball thread. Holy cow. So that's pretty much it for that part. And I think that what I'm going to do here is just close that, create a new part. Let's pick another one here. I really want to get into these big ones, but I don't feel like I have enough time today, but I might do another stream later this week to go through those because they are fairly involved, and I'm excited to tackle them. But let's just start with this handle ball here. To me, this seems like something that I would do with the revolve to create the sphere. I know that you could use a spherical primitive in the part workbench, but I tend not to use the part workbench because I don't feel it's as easy to use as part design and using sketches. I feel like a sketch-based workflow is more intuitive to me. It's something that it's the way I've been doing it for years and years, and not that the part design work or the part workbench and the primitives aren't a good way of doing it. I think it works for some people, but just not for me. And so that's why I'm going to approach this with here in part design. So let's just start with the sphere. Actually, I could technically do this with the hole up here and the outer sphere all in one shot. Because this is actually a tapered ream through here. I don't know this exact taper. I'd have to go look it up. But I'll show you how I could do this in one shot. And that is, what item number is that? Number 8. Okay. So let's create a new part, create a body within the part. Let's 8. Handle ball. Then we'll save this as 8. So let's turn on our planes. I'll just go to the XZ plane, create a sketch. I'm actually going to come in here and just draw a arc. Draw a line between them, those two there. Put the center of the arc at the center here. I know that's a 3/4 inch diameter. And then what I'm trying to do here is trying to get a tapered hole. And I'm going to draw a construction circle here. Make these horizontal. Give this a diameter. I want to leave it at that for right now. And then the last thing I'll do is add an angle to this between there and there. I'm going to call it 88 degrees. I don't know what that actual taper is without looking it up. I could do that sometime off the stream here. Again, I don't know. Oh, number 37 drill is 0.104. So maybe that's going to be the smaller end. Let's just call it this end for right now. 0.104. And maybe this is only a 1 degree taper, so. All right. So now if I take this sketch and do a revolve around the vertical axis, you'll see that I end up with a sphere with a tapered hole through the center. And I could always go back and edit my sketch here and change that taper angle if I go look up what the actual taper is and whether or not it's a smaller diameter at the far end than at this end. But we can always go back and change it later. So there's that. The next thing is this drilled hole over here on the end. And there's a couple different ways you could do this. One way would be to do a revolved cut. Or I could also use the hole feature. But I think in this case, it might actually be easier to just do the to do a revolved cut and it doesn't necessarily matter the orientation here. In fact, I'm actually just going to come back in here, pick the XZ plane, create a sketch, and then I'm going to come in here on this sketch, and I'm going to, I'm going to use the polyline and draw the cross section of what a drilled hole would look like. And again, we're going to revolve this around this horizontal axis, and then the diameter of that hole is 0.295 inches. I also know a drill point angle is 118 degrees, so this is a 59-degree angle. And the depth of that hole, they say, is ½ inch deep. So I'm going to add a horizontal dimension to this of a ½ inch. But then the hole is supposed to start out here at the outside of the circles, or the sphere. So what I need to do is I need to use the add existing external geometry. I can pick that radius. I could have actually turned on the sketch I used before and used that. That might have actually been a more robust way of doing it. But again, we can always go back and change that later. So now what I need to do is view my sketch head on. I need to make this point coincident with that arc, but then also with the horizontal axis. And now it is fully defined, and I can hit close, do a groove or revolved cut about the horizontal sketch axis and say okay. And now we have a groove or a hole in there. However, I think that my dimension on that is actually incorrect, and I'll show you what I mean by that. I want to come back in and edit my sketch. What they didn't really say on the drawing is that this hole depth is actually the depth of the full diameter, not the distance to the point. So I'm going to actually delete that dimension, and I'm going to pick this instead and make it ½ inch. And now when I come back and look at this, before, my hole diameter didn't clear the tapered cross hole in there when I was specifying the depth to the point of the drill. And now it totally clears it. So I think that is actually a more correct interpretation of that dimension. And in my day job, that's how we actually define our hole depths. We specify on the drawing that all of our hole depths are of the full hole diameter. So that way there's no confusion. So I'm going to turn off my datum planes there. And so let's just save that. And I think because I only have a couple of minutes left here, I'm going to stop right there, because to get into the sliding jaw and the base right here, I don't have enough time to get through those. But I guess I don't know if you all could answer whether or not you found this helpful. Did I go too fast? Was there anything confusing about it? I don't know. Just let me know. You can always leave comments on the video after it goes up on YouTube there. Feel free to hit me up on Mastodon. I'm just at Chris Huck at fostodon.org. And I feel like some of you that are here probably found me that way anyway, or got the link to the stream. So thank you very much. Happy to do it. This is actually, I like teaching people how to do this kind of thing, because there's often multiple ways to do things, and my way is just one way. But sometimes people have never seen that way before. So hopefully this is really helpful. And when I do another stream, I will post the link out on Mastodon there. And of course, if you subscribe on the channel, it'll show up there. And yeah, I'll see you all in the next stream. Thanks for joining.